Surface chemistry, in short discussion, I give the preliminary idea about surface chemistry. Now we consider surface chemistry. You know the thermodynamic equation, that is del G, means gives free energy equal to del H, enthalpy change minus T temperature, del S means entropy change. Okay, so as we know, del H when having more positive value, del G will be more positive, and that should be unfavorable, right? Because for spontaneous reaction, del G should be negative, gives free energy, that should be negative. So del H, if more and more positive and greater than T del S, so there should be unfavorable mean of reaction or process can be occur. Okay. So del H positive means what? Endothermic reaction. That should be heat needed. We have to provide some heat. But when del H equal to negative, that means exothermic. Some heat that should be released. Okay. Minus T del S. Del S means entropy change. Okay. Now adsorption, del H must be negative. For basically for adsorption process, del H, that is enthalpy change, that should be negative, means exothermic heat released. Now adsorption versus absorption. Adsorption is a surface phenomena, that should be sorption, we can call common term sorption at the surface layer of the materials or solutions. That should be the more particle can be soaked on surface area rather than bulk. That should be called as adsorption. And absorption, that should be more or less uniform distribution in bulk as well as surface. So that should be termed as absorption. Remind it, absorption and adsorption, there is B and there is D. Okay, by these two analogy, two letter D and B, we can say one is absorption, other is adsorption. Okay, now consider adsorption is a surface phenomena, what I tell. Okay, absorption is a bulk phenomena. Okay, adsorption, that is rapid at beginning process, that is when process that should be started, the rate that should be more than after going some time. Okay, absorption that having uniform rate. Now we consider what is sorption. Sorption is a process in which both adsorption and absorption that should be take place simultaneously. Both can be occur. That is bulk and surface both can have particles more or less simultaneously. Okay, means adsorption and absorption when take place simultaneously, that should be termed as common term sorption. Okay. Concentration of adsorbate when more in surface, we call positive adsorption. Okay, and concentration of adsorbate means which that should be absorbed, the materials that should be absorbed, and where the adsorption occurred, that should be called adsorbent. Remind it. One term is adsorbate, right? Means the material which absorb. Okay, which that should be absorbed. As for example, if chalk dust that should be given in the water and that should be adsorbed on the surface of the water solution, so we can say chalk dust is a adsorbate. Okay, BATE, adsorbate. But other one term is there that should be called adsorbent. That should be where adsorption take place. Okay, adsorption takes place. Same analogy. If chalk dust added in the surface of the water, so chalk dust adsorb on water layer. So in which place adsorption takes place? This is a water, right? So water is a adsorbent, B-E-N-T, okay, and chalk dust is a adsorbate, B-A-T, okay. Now we consider more surface area, so greater adsorption. When surface is more, so surface coverage that should be more particles that should be adsorbed, right? So that's why more surface area, greater adsorption. Okay. Greater critical temperature means greater van der Waals solution shaken with blood. Okay. Greater van der Waals force. Always remember, greater critical temperature means greater van der Waals force. This is defined. Okay. So greater critical temperature means greater van der Waals force of attraction, and so greater adsorption can be take place. When critical temperature that should be high, van der Waals forces that should be high. So due to van der Waals force of attraction, there must be greater adsorption. Okay. Now we consider there should be some example. That is dilute HCl solution shaken with blood. We give the negative adsorption. We get the negative adsorption. Okay. Now up to this we can conclude. Just more surface area, greater adsorption. Greater critical temperature means greater van der Waals solution. Van der Waals force of attraction, so greater adsorption. Okay. So temperature that should be inversely proportional to adsorption. Why? When temperature increases, molecules having better chaotic motion, so they are in motion and they are less, they give less tendency to attracted by the surface layer. Okay. And pressure that should be directly proportional. When pressure increases, attraction force increases, so that is more and more particles adsorb on the surface. Okay. So temperature inversely proportional to adsorption and pressure directly proportional to adsorption. Okay. When temperature is kept constant, the effect of pressure that should be high. Okay. Now we consider some isotherm. First one, Freundlich adsorption isotherm. That should be determined, that is x by m equal to k p to the power y by 1 by n, where n is greater than 1. N is any integral number. Okay. P is the partial pressure, I think, and that is must be x by m. X is the mass of the gas adsorbed on mass. Okay, mass of the gas adsorbed. And m is the mass of adsorbent at pressure P, and K and R, N are constant, depend on nature of the adsorbent and the gas that should be taken. Okay. Small x, that should be mass of gas adsorbed. Small m, mass of adsorbent. P is the pressure, particular pressure. K and N are constant, that should be depend upon the nature of the adsorbent and the gas at a particular temperature. So always remember, that is x by, if we plot x by m versus P, x by m that should be at y-axis and P pressure that should be at x-axis, we get the variation of curve at 195 Kelvin, 244 Kelvin, 273 Kelvin. That is like example. Okay. By varying temperature, we get this type of curves. Okay. So when pressure increases, x by m that should be definitely increases. Okay. Now we consider there should be another slope. That is, if we termed as an equation, we get that is log of x by m equal to log k plus 1 by n log p. Okay, log x by m equal to log k plus 1 by n log p. That should be, we can compare, that is y equal to mx plus c. M is the slope, c is the intercept. So we can say this 1 by n that should be slope m, and this log k is termed as c, intercept. Okay, we can say 1 by n, that should be slope, and log k, that should be intercept C. Okay. Okay, so that should be termed as log x by m versus log p. We get a slope that should be 1 by n, and intercept this, that should be log k. Okay, intercept log k. The factor 1 by n can have values between 0 to n. That is 1 by n value, that should be lies between of 0 and 1. Okay, probable range, that 0.1 to 1.005. Okay. Okay, so 1 by n, that should be having value between 0 and 1. That should become in many exams. Okay, short question MCQ, that is the value range of 1 by n in Fenn-Lewis isotherm. We have to know the equation, that is x by m equal to kp to the power 1 by n, or we can directly memorize, that is the value of 1 by n, that should be range between 0 and 1. Now, similar Fenn-Lewis adsorption isotherm, x by m, if we term as concentration rather than pressure, we can say x by m equal to k c to the power 1 by n. Similarly, we can get this equation, that is log of x by m equal to log k plus 1 by n log of c. By taking both sides log, we get it. Okay, similar type of gap that should be occur. Similar, there 1 by n is a slope, log k is a intercept. If we plot x by m versus log of x by m versus log concentration. Okay. Okay. Now we consider Langmuir adsorption isotherm. Langmuir adsorption isotherm. The degree of adsorption proportional to theta. Theta means what? That is fraction of surface area that should be occupied. Okay, degree of adsorption that should proportional to theta, the fraction of surface area that should be occupied. Means higher the fraction of surface area, higher will be the adsorption. Okay, more and more space for adsorption if there, so more chances for adsorption. So x by m proportional to theta, and if we omit proportional symbol, we get proportionality constant. So we can say x by m equal to k dash into theta. Okay. Now by this way, theta equal to kp pressure 1 plus k pressure. Okay, kp 1 plus kp. As theta proportional x by m, so x by m equal to k dash theta. X by m equal to k dash theta. So we put the value here. So x by m equal to k dash kp by 1 plus kp. Okay. Now if we convert this, so we get this equation, 1 by x by m equal to 1 plus kp by k into k dash p. P is the pressure. Okay. So we can say, that is, if we put in this side, we get ultimately this equation, that is pressure P by x by m equal to 1 by k into k dash plus P by k dash. Okay, P by x by m equal to 1 by k into k dash plus P by k dash. Okay, so we have this graph, that is if we plot, that is P by x by m at y-axis and P is the x-axis, we get this type of curve. Okay, theta is the fraction of coverage. Okay, fraction of surface area. Okay. Now we consider Fenn-Lewis isotherm. We get this, we get this, we get this, we get this. So this type of equation can be there at very high pressure. 1 plus Kp almost equal to Kp. Okay, 1 plus Kp, that is almost equal to Kp. That is, Kp value is higher, so that should be higher than 1. So we can say that is 1 plus Kp, that should be almost equal to Kp. If Kp value is much greater than 1, by summing up with 1 does not change too much the value, right? So we can say 1 plus Kp almost equal to Kp. Okay, so x by m, that should be equal to k dash. That should be a constant. Absorption isostar. Absorption isostar, that is if we plot, that is temperature versus pressure, we get a straight line. If we plot temperature versus pressure, we get a straight line. As we know, absorption is inversely proportional to temperature and directly proportional to pressure. When pressure increases, absorption increases. Consequently, temperature increases, absorption decreases. So ultimately, we get a straight line, this type. That is pressure and temperature both when increases, ultimate get no change almost, right? Both of things, both of effect can be cancelled with each other. Okay, so we get a straight line. We get a straight line, like for example. Now we consider catalyst. When we consider adsorption or absorption type of phenomena, we have to consider catalyst, because most of the catalysts are also, we can say catalysts are basically two types, homogeneous, heterogeneous. If we consider homogeneous catalyst, that should be soluble with the solution, phase is almost equal, so there is no chance or little more chance for adsorption. But when we consider heterogeneous catalysis, there should be a fixed surface area is there, and there should be hydrogen, most probably hydrogen are adsorbed in nickel surface, platinum surface, which are heterogeneous catalysts. Okay, so for studying heterogeneous catalysts, we have to know adsorption phenomena. So adsorption and catalysis, that should be interrelated property. Okay. Okay. Now we consider homogeneous catalysis. Catalyst and reactants phase same. If reactants are liquid, catalyst also liquid, they are miscible. So they react by this way. Okay. Okay. Now we consider heterogeneous catalyst, that should be phase different. As we say, that is they having fixed surface area, and there should be most of the cases hydrogen adsorbed. Okay, and by this way the bond between hydrogen atom, that should be big, and more adsorption can be take place. By this way unsaturated compounds to saturated compounds formed. Okay. Now we consider autocatalyst, when one product that should be act as catalyst, the product that should be formed, and this product act as catalyst. Okay, that must be called autocatalyst. Now we call enzyme. Enzyme is nothing but that is a biocatalyst, which most are found in humans, mammals, and so many creatures and plants also. Okay, enzymes little found in plants, but some enzymes are found also plants. Okay. Okay. So some examples are also given. That is must be enzyme. First one, sucrose, C12H22O11. That is the formula of sucrose or table sugar. Plus water and invertage is there. That should be produced glucose and fructose. Okay. Now glucose C6H12O6. When gymase react with glucose, it must be produce ethanol and carbon dioxide. That is ethanol and carbon dioxide. That is we better call fermentation. Okay. And starch, NC6H10O5 whole N. N is the unit, number of unit that should be present. The unit are C6H10O5. Okay, repeating unit. Plus NH2 react with diastase and produce maltose. NC12H22O11. The formula of maltose and sucrose, that should be same. That is C12H22O11. When maltose react with maltose, it must be produce maltose to glucose. Okay. Okay. Then urea, NH2CONH2, that should be react with water in presence of urease enzyme to produce ammonia, and carbon dioxide to produce ammonia and carbon dioxide. And also, pepsin enzyme convert protein to peptides. Peptide means nothing but linkage of amino acid. Okay, protein is the polymer of amino acid and peptide is a linkage of so many amino acid. Okay, while in intestine, the pancreas trypsin that should be convert protein into amino acid by hydrolysis. Protein is a polymer of amino acid. Amino acid is a unit of each smallest unit of protein. Okay. Now last one, lactobacilli is used to convert milk into curd. Okay, milk into curd, that is lactobacilli.